In this video, we are going to graph quadratic equations, and we are going to do that with three different forms. So let's start. Okay, a general characteristic of a quadratic. Well, that is going to have a term that is going to have x squared. So a quadratic equation will have some sort of term that has x squared in it. And what that's going to do is they are going to have a vertex which is going to be either at the bottom or the top of the parabola, depending whether it's pointing up or down. It's also going to have an axis of symmetry. That's going to be a line that goes right down the center of the parabola, passing through the vertex, that creates mirror images of each other. So this half of the parabola would be the same as this half. Same if I had a parabola that's pointing down, there's going to be an axis of symmetry going right down the center, passing through the vertex. Of course, this one's pointing down, so that would be a situation where we have a negative in front of the x squared. Okay, notice that on these two, in the first one, it's a parabola that opens up, the vertex at the bottom, and the vertex then would be the minimum. It would be the lowest point on that parabola. On the other one, we have the vertex is at the top. It's a maximum. That would be the case when the a value that's in front of the x squared is negative. Okay, let's talk a little bit about the axis of symmetry. Now, I will abbreviate it sometimes in the notes as AOS. Like I said before, that's going to divide the parabola into two mirror images of each other. And the axis of symmetry will always pass through the vertex. So if I had a vertex that's over here at h, here the x value would be equal to h, right? Then the line that corresponds to the axis of symmetry, that would be a x equals line, because it's vertical, it would be x equal to h. Here's another example. Notice that we have a axis of symmetry cutting right through the center of the parabola. Since the x coordinate of the vertex is a -3, the axis of symmetry would be x equals a -3. Because these parabolas create two mirror image halves, if I have a point that is one division on one side of the axis of symmetry, there has to be another point that's one division on the left of it. Same thing down here. Notice that the point over here is two divisions on the right of the axis of symmetry. There must be a point two divisions to the left of it. And that's going to make these things easier to plot. Okay, there are three basic forms that we are going to use to graph the quadratics. The first form is a x squared plus bx plus c, and of course that would be equal to y. The second form is the vertex form, a times x minus h squared plus k, and that looks a lot like the transitional form, and actually it is, but we're going to plot it a slightly different way. You already know how to do this in transitional form. And the third way is called intercept form, and I set it equal to 0 because that's how we normally do it, but really we should just say y equals a times x minus p in parentheses x minus q in parentheses, where p and q are going to be where the intercept form crosses the x-axis. Because if y would be equal to 0, well then we could set either of these two factors equal to 0, which means either x could be equal to p or x will be equal to q, and we'll talk more about that in a second. Notice that these things have a, and this one has an a, this one has an a, this one has an a. And those a's are going to do the same thing. If a is negative, it's going to point down. If a is positive, it'll point up. Let's talk more about that in just a second. So here's standard form. We said that standard form is going to be ax squared plus bx plus c. And if the a value is greater than 0, that means there's not going to be any negative on the a. We know from before in transitional forms these things will open up. If the a would be negative, that would be a negative in front of the x squared, that will cause it to open downward. Okay? Now in all these, the axis of symmetry, the point that's going to pass through the vertex, the line that passes through the vertex, the x-coordinate of the vertex, and the axis of symmetry, because it's passing through the vertex, will have the equation of x is equal to a minus b all over 2a. Here's the b, here's the a. So you're going to have to remember that. That's going to be really important. You can't graph standard form without knowing that. A little bit more about this is remember that we had these a values, and in transitional form we called that to be also the y stretch. So if the a value, whether it be negative or positive, that's going to be a number greater than 1, which means it's going to be like a would be equal to, like, say, it could be a negative 2, a could be equal to 2. Remember, that stretches the parabola. It's a y stretch. And as the parabola stretched up, kind of like a rubber band, it's going to get skinnier. So when the a values, the absolute value of a, is greater than 1, the parabola will get skinnier, narrower. If the a value is fractional, whether it be a is a negative 1/2 or a is 1/2, remember that shrunk the parabola in the y direction. It shrunk it vertically. And it's like a rubber band or something. If you push down on it, it's going to bulge out at the center. So it's going to be wider than the normal y equals x squared. Remember, we're comparing these to the parabola y equals x squared. That was the parent. That if the a value is fractional, it's going to make it widen out. And once again, we said the axis of symmetry would be at the equation x is equal to a minus b over 2a. That also means the x-coordinate of this point would be a minus b all over 2a, so what's the y value? Well, if I want the y value, I just put whatever this minus b over 2a is into the equation, and I would get y. So I would plug the x value in, and that's what this means. That means the function, the y value, evaluated at a negative b over 2a. So really, all this means is we're putting the x value into the equation and we're getting y. So this whole piece here, we can just think of this as being the y value. All right? And the other little piece to know is that, look at this equation form. If I would set x equal to 0, so if this x would be 0, this x would be 0, that what that's going to give me is that's just going to be y equal to c. Well, when x is 0, that would be on the y-axis. That's where x is 0, so that's the y-intercept. So the c value right here is also going to be the y-intercept value where x is 0. Okay? So let's go ahead and plot one of these. Here's the steps to plot. And I'm going to stop here for just a second. If you want to stop the video to write those down for notes, so just put it on pause. Other than that, I'm just going to go ahead and move down and work one of the problems using these steps. Okay, so let's graph this. Now, the first thing we're going to do is we need to find a, b, and c. So a is the 2. B is a negative 8, and C is 6. So, because the A value is a positive value, this is going to open upward. The y-intercept, remember, that would be C over here, because if I put 0 in for x, that would give me y is equal to 6, and the y-intercept occurs where x is equal to 0, so the y-intercept is 6. Now, look at the value of A. This is a number that's greater than 1. It's not a fraction, so actually that will be stretching this parabola in the y direction vertically, and so it's going to get narrower. So this would be narrower than y equals x squared. And the x-coordinate of the vertex, well, that's going to be at a minus b over 2a. So let's figure that out. That's also going to be the axis of symmetry. So the axis of symmetry would be equal to, let's try something. x is equal to a minus b all over 2a. That would be equal to a minus, and b is a negative 8 all over 2 times a. So that's going to be 8 all over 4 is equal to 2. So x equal to 2 is my axis of symmetry, and let's go ahead and put that on there. Now I'm going to dash it because it's not really part of the graph, but we'll use it to help us graph the equation. So this is the axis of symmetry. X is equal to 2. Now we also know that the vertex is going to be on the axis of symmetry, so we know that the x-coordinate of the vertex is going to be equal to 2, so my vertex will be at 2x, and now we need to figure out the y-coordinate, so I need to plug y, or the x, into this equation, and here's the equation. So 2x squared minus 8x plus 6. And let's put x equal to 2 in there. So that's going to be equal to 2. Now x is 2, so that would be 2 squared minus 8 times 2 plus 6. So 2 times 2 squared is 4 times 2 is 8 minus 16 plus 6. That would be equal to a negative 8 plus 6. It's a negative 2. So the y-coordinate of the vertex is a negative 2, and let's put the vertex on there. 2, negative 2. Let's label it. Okay, that's step finding the vertex. Now we need another point. So we're going to find a second point. One thing I could do is I could just pick any value for x. I could put x equal to 6, plug it into the equation, right? The equation is y equals 2x squared minus 8x plus 6. If I plug that in there, I could get a value of y and put it on the graph. However, that's probably going to give me a y value that's going to fall off the graph. So what I'm going to do is I'm going to look at my y-intercept. Remember, that's the c value, because that would be a really easy point to plot. That means setting x equal to 0, I could just see what that would equal. So if I set x equal to 0, my y value would be equal to 6, and that would be a point that I could use. Now when I plot this, if for some reason like this point would be real close to the y-axis, you may get another point that, say, looks like this. It's real close to the vertex. You cannot get a good feeling for how the parabola looks when the second point you plot is so close. So you'll have to use your judgment when you plot your second point. In this case, the y-intercept is a good distance upward, so I can get a good feel for how this parabola looks. So I'm going to use that. So my second point that I'm going to use, I'm going to actually use the y-intercept, right? So I plugged the 0 in and I got 6 out. So that's my second point. So I put that on the graph. And now I need a third point. Once again, I could pick any value of x on this side, because I've got a point on the left, and plug it into the equation, y equals 2x squared minus 8x plus 6, and get a y value. But in this case, it's going to be real easy just to plot the mirror point. Because remember, our y-intercept here is at 0, 6. That's 2 divisions away from the axis of symmetry, so I have a point that's 2 divisions to the right. Let's see if I can find this back. There it is. So I can draw my parabola. This point would be 4, 6, and my parabola would come down. Now it's rounded. It's not a absolute value that comes to a point. So that would be my parabola. And remember that for my third point, I want to write that down there. I used the mirror image, and we said that that would give me the point 4, 6. It was the mirror of the other one. So the last thing to do on this graph is to find the domain and range. The domain for a quadratic, remember, it's going to look like this. It could go as far out left and right as I want. So the domain is going to be all real numbers. So you could say x is equal to all reals. Now, if I wanted to use interval notation, I would move it like this. The domain goes from a negative infinity to infinity. The range on this particular problem, you can see that everything is above the value where y is equal to a negative 2. So the range would be y greater than or equal to a negative 2, and in interval notation, we would write it like this. It can equal a negative 2 and everything greater going to infinity. Okay, here's a second example, and it's what is in the book, so you can look at it. I'm not going to go over it, but it goes over finding the b value, finding the vertex and the axis of symmetry. So I'll just slowly go through there. You can stop it if you need to. Okay. Now let's go to vertex form. Now you already know how to plot this form. This is transitional form. Here's the y shift. Here, the y stretch or shrink. Here is the x shift horizontally. It would be h. Remember, h is opposite the sign of x, and k. Now we are going to do a little bit different on this. It's probably actually easier than doing the transitional form, which you're used to. So since the vertex, remember when we did transitional form, we said that the vertex, we would say every point would undergo a stretch and then receive the hk shift. Well, the vertex, because it's at 0, 0, can't be stretched. That would be like saying a times 0. So really, the vertex is going to shift just to hk, wherever it is. The vertex becomes hk. So I could look at this equation form, and I can find the vertex just by looking at it. It will be at hk. Okay, so that's how you're going to plot this, and you'll see that in just a second. Okay, once again, we have the same characteristics of A, so I won't repeat that. You can go look at that from what I did before. A greater than 0, it opens up. A less than 0 goes down. And whether the absolute value of A is greater than 1 or less than 1 determines how narrow it is. The domain and range are just going to be similar to what we did before. Okay, before we get there, let's do a couple quick problems where before we plot, we're just going to determine on these problems if it's going to open up or down, narrow or wider than y equals x squared, and state the domain and range. All right, so I'm going to do that real quickly here. So let's look at the first one. We can see that the vertex of this is going to move to, is that the first thing I'm supposed to do? Hold on. Find the axis of symmetry. Oh, the axis of symmetry is going to be at whatever the h value is. So for the first one, h is equal to 1, k is equal to 4. All right, so what we would see is that the axis of symmetry would be x equal to 1. Is it going to open up or down? Well, a is negative, so this is going to open down. The vertex will be at hk. So the vertex is going to be at 1, 4. Is it narrow or wider than the graph of y equals x squared? It's going to be equal to it because this is a negative 1. So the a value, the absolute value is 1, so this is going to be the same width. And the last thing is it says state the domain and range. Okay, the domain is going to be all real numbers. And because it's a negative, it will be flipped over, and the parabola will shift upward to 4. So That means if you can picture a parabola facing downward with the vertex up at 4 for the y value, we could see that the range then is going to be all the numbers that are less than or equal to 4. So we could write it like this. In interval notation, that means it's coming from infinity and it's going all the way up to where the y value is equal to 4. Remember, this is how we write in interval notation. This would be y is less than or equal to 4. Okay, let's go do another one. And I'll only do a couple of these. Let's jump over to this one here. We've got h is equal to 3, k is equal to 1. So the axis of symmetry, that's going to be at x equal to 3 because that's where h is. It's going to open upward because a is a positive number. The vertex will be at hk. Okay, hk, that would be at 3, 1. The a value is 2. That's going to mean that this thing is actually going to be stretched, so it's going to be getting thinner. So this would be narrower. Y equals x squared. And the domain, once again, it's all real numbers, so that's negative infinity to infinity. And the range, this parabola opens up, so the value of k would be the lowest point. The vertex is at a negative 3, 1, so the y value of the lowest point would be 1. So this is going to be one that would have 1 as its lowest point and going on for infinity upward. Okay, next one. Let's do one that's got a let's do this one here. Okay, for this one, h is a negative 2, right? K is 0. So the axis of symmetry is at x equal to a negative 2. The vertex, well, what's it going to do? It's going to open upward because this is positive. The vertex will be at negative 2, 0. As far as the width, now this is a fractional number, so this would be pushing the parabola, they'll be shrinking it, which means it's going to bulge at the center. So this would be wider. And the domain is all reals again. And the range, the k value is 0. So, and it's pointing upward, so the range would start at 0 going upward for infinity. Okay, let's graph one of these. All right, so let's look at what we have. We have h is equal to 3, k is equal to 1. So my vertex is going to be at 3, 1. Let's go ahead and put it on the graph. Okay, notice that it's going to open up. All right, now I need a second point. And I can pick any point that I want. If I would pick 0, you notice that I would have 0 minus 3, that's a negative 3, squared would be 9 times 2 is 18. This is going to go off my graph. So picking a point over here at 0 where x equals 0 is probably not going to work too well. Let's try x equal to 1. So I'm just going to pick the point x equal to 1 and I'm going to plug it into the equation. So plugging it into y is equal to 2 times x minus 3 squared plus 1, putting x equal to 1 in there, I get 2 times 1 minus 3 squared plus 1. 2 times a negative 2 squared plus 1. That would be a negative 2 squared is 4 times 2 is 8 plus 1 is 9. Okay, so when x is equal to 1, y is 9. So I'm going to plot the point 1, 9. 1, 9. Okay, now I did not put my axis of symmetry on there, which I should have done. Remember, that's going to be at x equal to h. So axis of symmetry is at x equal to 3. Now I have, I can use find my third point from the mirror. Look, this is 2 to the left. I guess I have to point 2 to the right. So that would be at 5, 9. All right, so let's go ahead and write over here. So I can draw my parabola. The domain, all reals, and the range is going to be all the numbers greater than or equal to 1, which is the k value. Okay? Here's another example. I'm just going to move it there slowly, and you can go through it if you want. This one is from the book. So pause the video if you want to look at it and see how it's done. Let's go on to another topic. Okay, intercept form. Okay, graphing in intercept form. This is by far the easiest way to graph. The reason is that we get 2 points given to us. Standard form, we don't get any. Vertex, we can find the vertex by looking at the equation. Intercept, we get 2. And this is all based on the fact that the x-intercept will occur where y is equal to 0. So that would be like if I put y equal to 0 over here, right? 0 is equal to a times x minus p, x minus q. There are several ways to get a 0. One way is if a is 0. Another way is if this whole factor x minus p is 0. Another way is if x minus q is 0. So what we're going to do is we're going to say, okay, let's find the place where x minus p is equal to 0. Well, what value of x gives me that? So what value of x would cause x minus p to be equal to 0? Oh, well, that's easy to do. X minus p equal to 0. Oh, x is equal to p. Over here, if we say x minus q is equal to 0, x is equal to q. So the points p and q, look, it's always going to be opposite the sign that's in the parentheses, are going to be where the parabola crosses the x-axis. That's the x-intercept. And we're going to use that to plot. We get 2 points just by looking at the equation. Once we have those 2 points, we know that the axis of symmetry is right between them. We can average those 2 points together, the x values, and we could find the value of the vertex that's right in the center. Okay, so you simply just average the values of the x-coordinates, or you could count over if you wanted. You go 1, 2, 3, 4. Oh, 4 between the points. The axis of symmetry must be at 2. Once again, the a values have the same function, so we don't need to talk about that. So let's go ahead and do an example. Okay, so here's the first one, and I have this y is equal to negative x plus 2 in parentheses x minus 4. Now what we said is that when this goes to 0, that would be one of the intercepts along the x-axis. So you could think to yourself, okay, x plus 2 equal to 0, x must be equal to a negative 2. Once again, I could just look at it and see that it's going to be a negative 2. So one of the intercepts is a negative 2, 0. Guess what? The intercept over here would be a positive 4. So I have 2 points that I can already plot. A negative 2, 0, and the point 4, 0. Okay, now to find the axis of symmetry, there are 2 ways I could do this. One is simply take the average of a negative 2 and 4. Okay, so the axis of symmetry, x would be equal to a negative 2 plus 4 divided by 2. That would be 2 over 2 equal to 1. So the axis of symmetry is x equal to 1. Okay, another way to do that is I can go 1, 2, 3, 4, 5, 6 points across between my points. So 3 would have to be 1, 2, 3 would have to be the axis of symmetry is also same place, x equal to 1. Okay, so now that I know where the vertex is going to be on that line, all I have to do is put that value of x into the equation. Okay, and this equation was a negative of x plus 2, x minus 4. Okay, so the x coordinate of the vertex would be 1, so let's substitute that into this equation. So that would be a negative of 1 plus 2 and 1 minus 4. That's going to be equal to a negative of 3. 1 minus 4 is a negative 3. That would be equal to 9. So I get the value of the vertex is 1, 9. And I can draw my parabola. Domain is all reals. The range is going to be all the values where y is less than or equal to a negative positive 9. So that means that it's going to be a negative infinity to 9. We always think about it as moving from lower y values to upper y values. Here are some more points. I'm just going to quickly tell you what the x-intercepts are. The intercept for this would be x is equal to a negative 4. X is equal to 3. How about this one? This x, what would cause this x to create a 0 over here? All right. Well, if this x is 0, think of it in just like this. It's in parentheses by itself. There's nothing added or subtracted. So for that one, x is 0. And over here, x is equal to 6. Those would be the places where it crosses the x-axis, right? Negative 4, 3. Over here, it would cross the x-axis at 0. Well, obviously, let's say that's 6 out there, right? 1, 2, 3, 4, 5, 6. So, anyway, let's keep going. Okay, the last topic here is to change to standard form. So let's say that I had some sort of an equation that I wanted to change to standard form. Here you can see that I have intercept form, right? And if I wanted to change it to standard form, I am simply going to multiply these two factors by the FOIL method. So what we could do is we would say x times x, that's the f in FOIL, that would be x squared. X times a negative 9 is a negative 9x. Negative 4 times x would be, obviously I did these notes at some point, that looks to be wrong, so let me just do it the right way. Okay, so y is equal to a negative of x times x, x squared, x times negative 9, negative 4 times x, and finally a negative 4 times a negative 9 is plus 36. So y is equal to a negative. Now let's combine the negative 4 and the negative 9. That would be x squared minus 13x plus 36. And then we distribute the negatives. So y is equal to a negative x squared plus 13x minus 36. And that would be standard form. Okay, let's do the next one down here. And once again, we're just going to multiply this out. Now remember, you do not distribute the square. This is x times 1 times x times 1. So it needs to be written like this. So we're going to multiply these two x minus 1's together. Okay, so x times x is x squared. X times a negative 1, negative x. This negative 1 times the x, all right? That would be the FOIL, right? F-O-I-L. So we're at the inners. Negative 1 times x, so negative x. Negative 1 times negative 1 is a plus 1. I'm making all sorts of mistakes whenever I wrote these notes up. So what we would have is 3 times x squared minus x plus 1 plus 8. That would be equal to 3 times x squared minus 2x plus 1 plus 8. Now distributing the 3, I get 3x squared minus 6x plus 3 plus 8. And that would give me 3x squared minus 6x plus 11. Somehow I got the right answer, so I don't know. The fact that I didn't have a plus here, I still seem to work it correctly. So, yeah, because look at there. So who knows? Anyway, I think that's it. Let's see what else is there. That's it.